So in the last video, I talked about how the identity matrix and translation matrix can work together to move things around. So let's add a third matrix into the mix. And as you can see, I am adding them, multiplying them all together to create a new result. And so let's take that scaling matrix, which I opened up the wrong thing here. And with the scaling matrix, it does probably what it sounds like. I can modify some values and scale things up. So that's pretty large. Let's shrink it all down. So 0.5. Look at it again. And kind of shrunk it. Cool, huh? So you take this diagonal of values and you just kind of modify them one by one. So if you want to, and let's actually comment out this translation matrix so it's not doing anything. So you can kind of see one by one what it's doing. So you can stretch it out that way, and what's kind of fun about the browser is you can still select everything after you've done these translations. And here, in 3JS, you can see it's going to affect kind of the depth, but in our CSS, it's not going to because it doesn't really know about depth. Then you can squish it and play around with it. So that's kind of fun. So let's go ahead and do something interesting. Let's multiply these by 2, let's say. That's a little big. Let's do, let's shrink them. So we've kind of shrunk them by half, and you notice I commented out the translation matrix. So the reason why I did that is because order matters with matrices. You can't just switch them all around. It's not like normal multiplication. In normal multiplication, if you do A times B equals C, then B times A equals C. That's not the case with matrices, and they're non-commutative. So checking this out, and just a reminder of the order these things go in. And we don't need this identity matrix here. It's not actually doing anything for us. In this case, we can see our translation matrix is, what order are these going in? Let's refresh. Yeah. So the order is scaling happens first, and then translation happens second. So if I switch those, what you're going to be able to see is translation is happening first, and if scaling happens second, it'll scale towards the origin. So if I'm a little bit more aggressive in my scaling, this might be more dramatic. So I'll do 0.1. So you can see they shrink towards the origin. While if I flip the order here, and the multiplication, you can see it doesn't do that. It actually scales first and then moves it. So sometimes if you want to rotate and move things, like if you have something over here off to the side and you want to scale it up and down, it'll actually scale out, like it'll move as it scales. So you have to actually translate first to the origin, scale it there, and then translate it back. So you have to do some funky operations sometime to get the proper transformation that you want to do. The order is dependent, and it's also based on some math stuff. So sometimes it just depends on the order you do them in, whether, like, for instance, in like GLSL, if you did like scaling matrix times translation matrix, the operations happen right to left. In my implementation here, they go top to down. So it just depends on how the math is done. It's kind of arbitrary, but you just pick one and just work with how it goes. To be honest, I just see kind of the direction that you need to do it in and work that way. Very pragmatic of me, right? Maybe I should figure it out someday. But yeah, that's kind of the order dependence of the matrices and introducing the scaling matrix. And next I will talk about the rotation matrix.